Welcome back, everybody, to our second session on electrical engineering, English for electrical engineering, that is. Our unit is about electric circuits this time, and we are going to be looking at electric circuits and their components. We are also going to identify the difference between series and parallel circuits. We are going to look at some text, so reading comprehension tasks, just like in the first session, as well as a quiz at the end of the session to check your understanding. Okay, so let's take a quick look at our first text. We are going to read the text first, and then there will be a picture where we will have to write down the names of the different parts. So let's just read this one quickly. An electric circuit or network is a pathway through which the electric current can flow. A simple circuit consists of a power source, two conducting wires, each one attached to a terminal of the source, and a device through which electricity can flow. This device is called a load, and it's attached to the wires. If all the parts are properly connected, the current flows and the lamp lights up. This kind of circuit is called closed circuit. On the contrary, if the wires are disconnected, the circuit is called open or broken. The circuit can be opened and closed by a device called a switch. Loads can turn electrical energy into a more useful form. Some examples here: light bulbs, which change electrical energy into light energy; electric motors, which change electrical energy into mechanical energy; speakers, which change energy into sound. The source provides the electrical energy used by the load, and it can be a storage battery or a generator. The switch interrupts the current delivered to the load by the source and allows us to control the flow. When an abnormally high amount of current passes through a network, you get a short circuit. This may occur when there is a drop in the resistance of broken insulation, for example. To prevent short circuits, it is best to use fuses, which melt when too much current flows through them, and this interrupts the circuit. Right, so this was our first text. Let's have a quick look now at this picture here. Once again, if you have the worksheet with you, then you can go back and forth between the text. This is more like a way for you to be able to check the answers. So here we've got load for number 1. The switch here is number 2. Number 3 was mentioned in the text, and that is the fuse. Number 4 is cable or wire, and number 5 will be the power source. It is a battery in this case. So load, switch, fuse, wire, and power source. Right. Matching the words with their definitions is our next task. Here on the left you have got load, switch, source, fuse, closed circuit, and broken circuit, and the definitions on the right side. A device which interrupts the circuit, a circuit in which wires are disconnected. C, a device which provides power. D, a complete circuit with no breaks at all. A device which consumes electric power is E, and F is a protective device. Feel free to take a screenshot and connect the words with the definitions. For now, for us, let's just check the answers. So load will be a device which consumes electric power. So number 1 is E. Which one would be switch? The switch will be a device which interrupts the circuit. A. Source will be the device that provides power. Fuse is a protective device. A closed circuit is a complete circuit with no breaks, and a broken circuit is a circuit in which wires are disconnected. EACFDB. Right, okay. Answering comprehension questions now. This again, to check your answers. What does a simple circuit consist of? It consists of a power source, two conducting wires, and a load. What happens to a lamp in a closed circuit? It lights up. Can you name some examples of loads? Well, of course we can. Light bulbs, electric motors, and speakers. What is a generator? An example of loads. Still. Number 5. What's the function of a switch? It controls the electrical device. When does a short circuit occur? Well, it occurs when there is a drop in the resistance or if there is a broken insulation. What can be used to prevent short circuits? Fuses, of course. How does a fuse work? Well, it melts when too much current flows through it, when there's too much current. Hence, it breaks the circuit. Okay, our next text here. Complete the text with the words in the box, then listen and check. Well, this is the listen and check part. So, let's have a quick look. The components of a circuit can be wired in two different ways, series or parallel. If components are arranged one after another, so that's the keyword, one after another, to form a single something between the terminals and the components, the circuit is known as a series circuit. With a series circuit, there's only one path, a single path. So number 2 here is path. In this type of circuit, the current flows from the negative terminal to the, from negative to the positive, of course, passing through all the other components of the circuit. This means that the amount of energy passing through all the components in the series is the same. Okay, so same amount of energy. The main disadvantage of series circuit is that when a single component in the path burns out or fails, the entire circuit stops operating. For example, a Christmas tree light. Right. A parallel circuit consists of several paths connecting the different components. Each separate path is called a branch of the circuit. Current from the source divides and flows through the different branches. So as you will see here on this image here on the left of your screen, this is a parallel circuit. Okay, while in the series circuit there's only one way to go. You will see that here the current can flow in different directions as well. So there are junctions where it can continue straight on or turn left or right. Okay. Unlike series circuits, if one of the components in the parallel circuit burns out, the other paths will still be able to operate, so continue to operate. Parallel circuits are commonly used to connect appliances at home so that each socket can function independently. You don't have to turn on the light in your room for the TV socket to work. Right, there we go. Branch, continue, appliances, and turn on. Right, and we have got one more text. With this text, we are going to have to read it and then find synonyms to the words at the bottom of your screen. So, a fuse can be added to an electric circuit to protect it from the effects of undue power. This safety device, which is made of a heat-sensitive alloy, is connected in series with the circuit it has to protect. If an excessive amount of current flows through the circuit, the alloy will liquefy and open the circuit. The circuit breaker is fundamental in a house to protect the circuits against overloading, overheating, and short circuits. The advantage of a circuit breaker is that it can be reset after the overloading by replacing the fuse. A professional electrician should always provide customers with a map of the electric circuit in the house so that it will be easier to work on it in case of faults. Right, so fuses, they melt, and this is how they will protect everything else in the house. So you don't have all the wires in the wall melting and burning and causing fire, because as soon as this fuse melts, the circuit is broken, and that's how it can protect your TV, for example. Right, finding synonyms: excessive, undue, reacting to high temperatures, heat sensitive. To melt is to liquefy, turn into liquid, liquefy. Loading up, loading up, overloading, same word. Adjusted, reset, and clients, customers. Okay, so these were the three texts that we had to read, that we've gone through. Let's have a look at a quick quiz right now. You'll find the quiz if you go to quizzes.com and look for electric circuits. I've got a couple of screenshots here as well that we can practice right here. So let's have a quick look. What material would be the safest to use as an insulator to cover electrical wires? Which would be the best as an insulator? Water, aluminium or aluminum, tin or rubber? Out of these here, our best of answer would be, I realize I've got okay, well, never mind, at least we can see the date there as well. So yeah, rubber, of course, rubber insulator. What is a circuit that only has one path for electricity to flow? Only one path. That is, of course, a series circuit. Right, what kind of a circuit is this one? Here you see two examples: parallel, consecutive, series, or training. This is, of course, series, or these are examples of series circuits here. Why is electrical wiring usually made from copper? Because copper insulates electricity, because copper conducts, because it's shiny, or because it's not magnetic. The correct answer, of course, is because it conducts electricity. What is a circuit with several paths for electricity to flow? Parallel, conductor, series, or open? Parallel is the answer that you are hopefully shouting at your screens now. Alright, here we go with the next one. Choose the correct sentence. Alright, so look at the picture now. This circuit will not work because it is an open circuit. This circuit will work because it is an open circuit. Will work because it's a closed circuit. Will not work because it's a closed circuit. Two things we have to decide here. One, is it gonna work or not? Is it an open or a closed circuit? It's, in a way, it's the same question. Now you will see that the switch at the top, you will see that the switch is open. So this is an open circuit. We are left with option number 1 and 2. Now the question is it gonna work? What do you think? Well, if it is open, then clearly it is not going to work. Oh, yeah, wrong way. Yeah, so it's not gonna work because it is an open circuit. All right, an incomplete circuit is shown here, okay? Which 2 points would need to be connected to make it a closed circuit? So what would you need to connect? Let's imagine that I'm giving you a piece of wire. Would you connect A to B, A to C, A to D, C to D, whatever? Well, hopefully you've got this one right. You would need to connect, of course, A to D. Okay, A to D. All right. What kind of circuit is this, or what are these examples of training consecutive, parallel, or series? This one again will be a parallel circuit, and I think we have one more. Yes. What type of circuit is represented in this image right here? Closed, open, series, or parallel? This will be a parallel circuit, although at the same we could also call it a closed one. We don't need redemption question because we've answered everything correctly. And with that, yeah, we've come to the end of today's session. Hopefully it was useful. If you have any questions, you can ask me either in the class or right here. You can write a comment. Thank you for your attention. Have a lovely day, everyone, and I'll see you again soon. Goodbye.